Every day, the future's getting closer.
Welcome to Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host, and welcome to today's podcast. Well, hello everybody. Welcome to another episode here at Master the NEC, sponsored by Electrical Code Academy, where we talk about the National Electrical Code. My name is Paul Abernathy, as always. Welcome to the podcast. We appreciate you listening to our podcast for these many years that we've been producing them, as well as all of you that date all the way back in the early 2000s when you used to listen to the Electrical Guru podcasts. We appreciate you listening. Hopefully you learned something from it. Now, today's episode, we're going to be very specific. We are going to talk grounding electrode systems. And we're going to talk about the electrodes that are associated with the grounding electrode system. And so we're going to be very focused on the electrodes and the different types of electrodes. Now, this podcast is probably for the apprentice and the journeyman who wants to understand the different electrodes that are available on the market, whether it's inherent to construction or something that you would have to install yourself. And so we're going to look at that. We're going to spend most of our time in two sections, dot 50 and dot 52 of Article 250, because that deals with our general rule of a grounding electrode system. And then, of course, we get into the different types of electrodes that we're dealing with. Okay. And so we're going to try to focus on that in this episode to keep it short as possible, and we'll just do it in different segments. So let's talk about your grounding electrode system. Under 250.50, and I should remind you, we're in the 2017 edition of the National Electrical Code. I use the electronic version, the PDF version, but I do have the hardback versions as well. And I get all my PDFs and everything from NFPA, help support their cause. But however you get your code book, we're working on the 17 code at this time. Okay, so we're in part 3 of Article 250, which are dealing with grounding electrode systems and grounding electrode conductors. Now, we've talked about the GEC, grounding electrode conductors, and other videos and podcasts. So today we're going to try to talk about the grounding electrode systems as a whole when we deal with what we're talking about is the electrodes itself. So that's where we're going to spend our time kind of giving an overview of these different types of systems. The first things first, we want to read Section 50 of Article 250 in order to get an understanding what a grounding electrode system is and what's made up of. And so I will read it straight out of the code for you that are following along. It's in page 115 of the PDF version, and in the print version, it's on page 112. Okay? Now it says, grounding electrode system, what does it consist of? It says a grounding electrodes as described. All grounding electrodes as described in 250.52A1 through A7 that are present at each building or structure served shall be bonded together to form the grounding electrode system. Now that's important because it used to say years ago that are available. If you argued that it wasn't available, then you didn't have to tie them together. You didn't have to bond them together. But now if they're present, whether you intend to use them or not, it's irrelevant. You will bond them all together, okay? So we're just going to keep this at new construction because there is an exception for concrete encased electrodes in this application, but we're just going to keep it where we're at. So A1 through A7, all of these type of electrodes have to be all bonded together if they're present. Now, not all of these electrodes are going to be present, okay? But if they're present, you're going to tie them all together. Now, it says where none of these electrodes that we just talked about, where none of them exist, and when we say A1 through A7, we're talking about a metal underground water pipe, we're talking about a metal in-ground support structure, which is kind of new for the way it's bringing it out is new in the 2017 code. Concrete encased electrode, that's A3. A4 is a ground ring. A5 is rods and pipe electrodes. A6 is other listed electrodes. Okay, there's going to be some chemical type things that are other listed ones. 7 is a plate electrode. So that's your A1 through A7. Okay, and then you have 8, which is called local metal underground system or structures. And that could be an underground tank or pipe system. But in the general rule, we're talking A1 through A7 first. Okay, and then of course you're going to see where A8 will come into play in that application. All right, so if A1 through A7, the ones I just mentioned, are present at the installation, then they all got to be bonded together. Now, where none of those exist, then I'm allowed to kick into the one or more of the grounding electrodes specified in A4 through A8. Okay, so why do we say it this way? Well, you could have A1 through A7 all part of new construction. However, typically A1 through A3 are products of the actual construction. In other words, you might have metal underground water piping supplying the building if it qualifies, and we'll look at that in a minute. Typically, that's probably today that's more plastic, but you could have a metal underground water pipe that supplies the water to the structure. And then the metal in-ground support structure is literally like taking an I-beam and driving it into the earth, okay? And that'd be with or without concrete encasement around it, because there are some buildings where they literally drive the I-bar down into the earth, okay? And that would be considered a metal in-ground support structure in contact with the earth. We'll look at that in a second. And then, of course, concrete encased electrode is something that's inherent with the construction, okay, of the foundation, if you will. Now, you could have what's called a visqueen or a vapor barrier down that makes it not a concrete encased electrode. We'll talk about that when we get to A3. But those three are inherent in construction. And then, of course, A4 through A8 is where you get into the kind of the things that get added. Okay, it used to be referred to things like man-made, whereas a pipe or a rod or a plate or other listed electrodes which are designed, maybe it's a chemical base where you put a certain type of chemical in it and it goes in the ground and it's designed for its intended use. In other words, it's listed for that application, that type of thing. And of course, like we just talked about, you could have existing on-site metal underground system or structure like underground tanks or piping systems or metal well casings or whatever. All right. And you could have some of those aspects that are involved. Okay. So, but you can't get there if any of the A1 through A3 are present. Okay? And if any of the A1 through A7 are present, then you have to tie them all together. Okay? So I hope you get how that ties together. But if none of those are present in the installation, then it kicks me into A4 through A8. And that's typically, for most people, they're going to go right to ground rods. I mean, that's what they're going to go to. Again, it used to be considered like man-made, but we got rid of that terminology, man-made. So that's kind of how it rolls there. I will keep you in mind that any of the ones that you add in A4 through A8, if you install them, they have to be used, and you do have to bond all those together. Okay, so you're not losing anything in that concept of bonding them all together. We're just determining whether or not they're there or not, and then you move on to, well, they're not there, so I can use A4 through A8, and I can use one of those types of electrodes. And we'll look at each one of those for clarity. Okay. Now the exception is driven towards, well, what if I have an existing building or structure and I'm doing something to that and I'm changing the service or I'm adding the service or I'm expanding or making some kind of change, and the steel reinforcing bar or rods are not accessible, okay? And I don't have to disturb the concrete. Now, the rule states, and I'm going to read the rule because it's important to understand an important statement that's in the exception, and we'll talk about that as far as the importance of the statement. And let me read the exception. Now, remember, we're talking about grounding electrode system and the tying of all of these electrodes that are present together. It goes on to say, well, here's an exception. It says, concrete encased electrodes of existing buildings or structures shall not be required. So this is a permissive rule here. Shall not be required to be part of the grounding electrode system where the steel reinforcing bar or rods are not accessible for use without disturbing the concrete. So they're concerned about disturbing the integrity of the concrete. Okay, so it's not required for you to chip it up to get to it. Okay, and that would be for an existing building or structure. Now, the one thing that I encourage people to understand that we're looking at shall not be required. Now, an engineer might still want you to do it based on their calculations, based on where they're making this connection, and they say it's not going to interfere with the integrity of it. Well, the code says one thing. Again, it shall not be required. So that takes us back to some of those rules that are in the Article 90. Most notably, we want to look at 90.5. Now, that is the mandatory rules and permissive rules. Okay? And when we look at a mandatory rule, it's a code rule that says, look, if it says shall or shall not, then that's a specific requirement or a prohibition from doing something. Whereas a permissive rule might say shall be permitted or shall not be required. Means that you can do it, it's just not required. So it identifies a specific action that might allow you to do something. It might be an alternative method to doing something. However, it's not a requirement. Whereas if something said shall not, then or shall to do something, that is a specific requirement and it identifies that specific action. So it's important to understand the difference between a mandatory rule and a permissive rule when we get into the National Electrical Code. Okay? So that's just the key I wanted to talk about when it comes to that. Explanatory material, which is item C in 90.5, dealing with C. Then that's just talking about informational notes, things like that, which are not enforceable. Great information. I love informational notes. I love informative annexes. All of those applications that give you guidance through the NEC, kind of roadmaps through the NEC, suggested information, other standards to look at maybe, or things to take into consideration, but they're not enforceable in themselves. So always remember that when it comes to that. Okay? An informational note is just that. Great information. All right, so let's get back to where we were at. So when I'm dealing with 250.50, I have now laid out the concept of having to tie or bond all of these electrodes together. Even if they're not present and I have to add one or more of them based on the rules in 250.50, I'm still going to tie them all together and I'm going to use them. If I add them, I have got to use them. In other words, I have to tie them together. Can I have more than one? Most certainly. Do I always need more than one? Not always. With a metal underground water pipe, you have to supplement it. Okay. With a ground rod, you can't install just one. You have to add two unless you can show that it's 25 ohms or less. Then you can reduce it down to one. Okay. That's a change from years ago where you installed one and then you had to prove it. If you couldn't prove it, you installed two. Now it's kind of the same concept, but you install two. And if you can prove that it's 25 ohms or less, then you go to one. That's essentially supplementing the first ground rod. So we get around that by just saying install two, and then you have to prove some information to be able to reduce it down to one, if you will. Okay. Most of the time, it's just simply, people don't own a ground resistance meter, 3-point fall of potential, or a clamp-on that does that because they're expensive. So they just say, look, it's cheaper to grab a second ground rod. Make sure it's at least 6 feet away from the other ground rod. It could be more. In fact, most of the IEEE standards, whatever, recommend you to be the same separation as the length of the ground rod. But the code only says that it has to be at least 6 feet away from the other ground rod, and of course it could be 7, could be 6.5, could be 8. It really doesn't matter. It just can't be less than 6. Okay, so let's talk about, and we'll look at each one, but let's talk about the electrode types now. All right, the first one that you're liable to encounter if you start dabbling in the code, start learning the code, is a underground water pipe of the metal type, obviously. It's conductive, whatnot. There's a lot of surface area on that metal underground water pipe. Typically, the water pipe coming into a building, I'm going to say typically because I'm not a plumber, but it would be something like a 3/4. It's a lot of surface area that makes contact with the earth, allowed to dissipate that lightning, that surge, that transience. Again, these electrodes are not to clear overcurrent devices. It's not going to happen. Okay, they're not for that. All right, so never fall into that trap when you're talking about grounding electrodes about trying to clear any overcurrent device. Okay, a simple Ohm's law calculation will show you that that's not possible. All right, so electrodes. Very first one, A1. It's a metal underground water pipe. Now I'm going to read it and we'll discuss it. It says a metal underground water pipe in direct contact with the earth for 10 feet or more, including any metal well casings bonded to the pipe, and electrically continuous or made electrically continuous by bonding around insulating joints or insulated pipe. So you have to have that jumper and sizing that bonding jumper to the point of connection to the grounding electrode conductor and the bonding conductors or jumpers if installed. Okay? So you might have bonding jumpers over meters, depending on where they take the grounding electrode conductor to. A lot of times they take it on the the load side of the water meter, and you still got the side that's in the earth, so you got to size a bonding jumper over that water meter. Most prudent people will go to the supply side of that water meter and make that connection, so there's no meter in between it. So if somebody removed the meter, you lose that integrity of the system, so that's why you'd have to have that bonding jumper on it. So just kind of think about that in your install. But again, it's literally 10 foot of pipe. You notice that we don't give a size here. We don't say it's got to be 1/2 inch, 3/4, 1 inch. It doesn't really give you that. It's just 10 foot or more in contact with the earth. Okay, so that's the basic rule for that. Now, most installations today, new modern installations, are probably going to have PVC. They're not going to be metal underground water piping. They're just not. But you have to understand, if there is, then that is an electrode, and that is going to have to be bonded to the other electrodes that might be in the building. Now, when you're dealing with the metal water pipe electrode, you have to understand that if I'm dealing with it, that it does require a supplemental. Okay, and that would be under 250.53, I believe it's D2, where it's supplemental electrode is required for the metal underground water pipe. Okay, so that is a case where you're going to have a supplemental. Now, why would you do that? Well, if I have a metal underground water pipe and for some reason it's replaced at some point with PVC or whatnot, or something gets fixed on it or repaired on it or whatever, then the integrity of that underground water pipe could be breached, and so we have to supplement it with another type of electrode in order to be able to maintain that grounding electrode system. Okay, so that's something. It's also important to understand that you can't supplement the water pipe ground with another water pipe ground. Okay, you have to choose one of the ones in A2 through A8 to supplement it. Okay, and so keeping that in mind, and of course, if that supplement is a rod, pipe, or plate, it has to comply with 250.53A, okay, in all that applications. And A tells you that it has to meet 250.53A1 through A3, and that talks about the spacing, like I said, not less than 6 feet apart, in all this type of thing. And of course, also the supplemental requirement, if you're using a single rod, that kind of makes you put 2 in. You get it, right? So you got to meet, and it talks about how you drive it below the permanent moisture level, which probably people never do. Okay, but it does tell you there. So probably 250.53A1, the requirement for below permanent moisture level is probably the one that's most violated. Although it does say if practicable, which people argue the term if practicable to do that. Look, if I could drive it down to the earth, then it is practicable for me to drive it down below the moisture level. Most people just don't do it. Okay, all right. But we'll let somebody else argue for the practicable or why that terminology is in there. I'm not going to do that today. All right, so we've covered that. So that's the metal underground water pipe and its requirement for it to be supplemented by any of the other electrodes that are permitted here in A2 through A8. Any of those could be a supplement to the water pipe. So in other words, I can't just go with the water pipe ground and that's it. I'm done. Okay, got to have a supplemental to that. The next one is new for the 2017 code. It was actually new in how it was kind of written because before it kind of intermixed with the building framing, and it had requirements, for example, for connections to a concrete encased electrode and all these other nuances that were involved in it. And what we've done is pretty much moved that over into 250, and I believe it's 250.64, where we talk about And let me double check so I can make sure and I'm talking about that right. Let's see here, because I want to make sure I get into the different aspects of it. Actually, you know what? I think it's 250.68. That's where it talks about it. And that allows me to utilize, for example, the metal structural frame of a building, which is a little different than what we're talking about in ground, the one we're going to talk about here in a second. This really talks about where I can use the metal framing of a building to actually extend as a grounding electrode conductor or as a bonding jumper connection to grounding electrodes. And so we have two little aspects of it now. So we want to stick with not using these structural framing members of the building as a grounding electrode conductor, if you will. We want to keep it as talking about electrodes. And that was a big change when it did that, because now we're able to strictly stick with what's considered the electrode. And that is the metal in-ground support structure component. That's what we're really focused on. Okay? So if we look at 250.52A2, you'll have an N in there in the side column or the middle. You'll see it next to the 2. And that says that this is new. This is new material, because what we did was we took the other and moved it to 68.68 because we're really just trying to extend connections between electrodes, or when we can use the building framing for this purpose, versus it was so hard to determine whether or not it was an electrode or not. And it was hard for inspectors to be able to verify that. So let's read 250.52A2 and understand what we're talking about. It says, metal in-ground support structures. It says one or more metal in-ground support structures in direct contact with the earth vertically for 10 feet or more, with or without concrete encasement. So it could be driven down, pneumatically, impacts, whatever it is, or it could be put in the ground with concrete around it. All right. The other thing you'll notice here that it says vertically. Again, it's a support structure to be driven down vertically, not horizontally. Okay. And it's in direct earth for 10 feet or more, with or without concrete. Now, if multiple metal in-ground support structures are present, which you are on a building, you're going to have a bunch of them. Okay. It shall be permissible, again, permissive statement, to bond only one onto the grounding electrode system. So I don't have to loop all these around. Okay. There are people that do that. I've seen specifications that call for that. What's the point? Okay. You can only squeeze so much. What's the old saying? You can't squeeze 10 pounds of crap in a 5-pound bag. So understand that there are limitations to these installations that you get to follow. Now, could you connect it between all of them? Certainly, because it says it shall be permissible to bond only one. If you want to bond them all and you think that that's going to benefit you and you want to do that in the design, all you're doing is driving up the cost of the installation. More copper and more manual labor trying to connect all these together, and it's not going to really serve you any additional benefit. Okay? All right? So it's permissible to do this. So that is the metal in-ground support structure component. Think of it like the I-beams. You've seen it. Steel I-beams, literally driven into the earth for 10 feet. It's not going anywhere. That's where they're building the support component for this building. Sometimes they're in concrete. Sometimes they're just driven into the earth. There's enough surface area that is actually going to be an adequate electrode. Okay. Now you notice that it doesn't say anything about having to supplement that. There's not a supplement requirement for that. That could be your only electrode. If that's the only one, then that's it. You don't need to do any more. Also, there's an informational note. It says metal in-ground support structures include, but are not limited to, pilings, casings, and other structural metal. So while I gave you an I-beam example, that might not be what's actually driven. It could be a pole, a round, a casing, whatever it would be. If it is driven 10 feet in earth or more, then that could be utilized as a metal in-ground support structure. The key issue here is metal. Okay, your engineers will figure that out. Okay, most of the time I see them as other support metal I-beams that are actually driven. Okay, but I could have a metal casing that is also filled in with concrete, but you still have the metal casing that's in contact with the earth 10 feet or more, and that would qualify. And I don't need a supplement to that. The next one is your concrete encased electrodes. Some people refer to as a UFER ground, made famous by Mr. Herbert UFER, who actually did his testing in the 60s on a military bases and found out, I believe Arizona and other places, that he found out that as far as economical wise, a concrete encased electrode gave you the best bang for your buck, because what it did was it put rebar or bare copper, not smaller than a 4 gauge, encapsulated in concrete, okay, in contact with the earth. The concrete absorbs moisture. That in connection with the connection made to the rebar. Remember, this is a system. It's not just the rebar. It has to be concrete encased in order to be able to function properly. And there's length limitations on it. When you create this, then it makes good contact with the earth, and it makes an excellent electrode. Now, the thing about this is that usually in construction, most all constructions will give you a concrete encased electrode. So obviously it's present. So while they might design something with ground rods, if there's a concrete encased electrode present, you've got to connect to it. And so the one thing that people will say is, well, what if they have a plastic vapor barrier down? In some jurisdictions, depending on water tables and what you're dealing with, and I'm not a building code guy anymore, then you might have this vapor barrier down. And if that's the case, and there is a physical separation from earth and the concrete encasement, or this footer, then what happens is you don't have a concrete encased electrode. Okay. Now here's the other thing. People say, well, maybe the AHJ will let you come and cut an open path in that vapor barrier. Well, I don't know, man. If the jurisdiction required you to put a vapor barrier down, there's a great chance they're not going to let you come by and cut it. That kind of defeats the purpose. So you have to understand whether or not vapor barriers are required, or whether they're just optional and you put them in because you want to. And if you put them in because you want to, then what I would suggest is simply, and it wasn't required, I would simply cut some of this vapor barrier out to expose 20 feet of this concrete encased electrode to the earth, and then you've got your concrete encased electrode, and you don't really need any other electrode. You don't need to supplement it with anything, and it's already part of construction. So at the end of the day, electrician, it didn't cost you anything. Only thing it costs you is the conductor that you need to have to go down to get to it. Okay? And 250.66, you have an A, B, and a C. And the 250.66 is going to say, well, if you're dealing with a concrete encased electrode, well, if that's the case, then it doesn't have to be any larger than a 4 AWG copper wire. And so it doesn't matter what size the service is. The wire for the concrete encased, for the grounding electrode conductor that goes down to this concrete encased electrode doesn't have to be larger than a 4. Okay? And that's allowed under 250.66b. So if you think about it, that's one of your most economical ways, and I would argue that it's even cheaper than ground rods because it's already there. You don't have to have somebody drive rods or buy two and drive rods and do that. You see what I'm saying? So pound for pound, it's great. Now let's look at it and understand the nuances for concrete encased electrodes. Again, some people call them a UFER ground. That's UFER. It says a concrete encased electrode shall consist of at least 20 feet of either 1 or 2. Okay, so number 1. Now, number 1 is inherent usually in the construction of most projects. Whether it's, well, of course, now they have systems that don't have rebar in them. So I guess they wouldn't qualify as a concrete encased electrode because you got to meet these rules. And let's read it. It says one or more bare or zinc galvanized or other electrically conductive coated steel reinforcing bars or rods of not less than ½ inch in diameter, installed in one continuous 20-foot length, okay, or if in multiple pieces connected together by the usual steel tie wires, exothermic welding, welding, or other effective means to create 20 feet or greater length. So I can have a 20-foot piece of this half-inch rebar, or I could have 21-foot pieces that were connected together with steel tie wires, exothermic weld, or other effective means. And again, I would probably say that the majority of the time this is going to be this traditional steel tie wires, creating physically 20 feet or greater of rebar. Or I guess if it wasn't rebar, it could be a rod, okay, that's not less than a half inch in diameter. And connecting all these together, then that would be adequate, and that's my concrete encased electrode. Remember, in contact with the earth. We'll see that in a second. Okay, we'll talk about that part in a second. Okay, so this is the sheer construction of it. The other option is bare copper conductor, not smaller than 4. So since I can run 4 to it, and that's all was required in 250.66b, then clearly the electrode itself would not be required to be any larger than a 4. Of course, an engineer can spec it larger if they want. It's really going to serve no additional purpose as far as the codes as a minimum standard. And that has to be 20 feet of it. Okay? 20 feet of it installed. All right? So that's what we're dealing here in this application. Bare, not smaller than 4 AWG, not pieced together either. This is 20 feet of number 4. Okay, I shouldn't say number because they don't use numbers anymore in the NEC. It's just 20 or more feet of 4 gauge copper. All right, now let's get into the components here. It says the metallic components shall be encased by at least 2 inches of concrete and shall be located horizontally within the portion of the concrete foundation or footing that is in direct contact with the earth. Okay, so horizontally. Okay, it used to be a certain distance. Now it's just making sure that you're in the portion that is horizontally in contact with the earth. It does have to be encased in 2 inches of concrete, so 2 inches all around it. Okay, which obviously is not going to be a problem in the foundation or the footing. In direct contact, or you can also go vertical with it. If it's within vertical foundation or structure components or members that are in direct contact with the earth. Okay? So we still have the 2 inch. The or says it can be either horizontally or vertically, but you have to meet either one of those requirements. It doesn't remove the 2 inch encasement part of it. Okay? A lot of people read that wrong. They get to the or and think, or in a footing that is in direct contact with the earth, and they read all these ors, and then they think that doesn't still apply to the 2 inches encasement. No, that's the start of it. The ors are the different options from vertical to horizontal applications. It also goes on to say, you know what? Let's remember what we did for the metal in-ground support structure. It says, look, if multiple concrete encased electrodes are present at the building or structure, it says it shall be permissible to bond only one onto the grounding electrode system. So I don't have to loop all of these around. Okay? Because I could have a concrete encased electrode that's vertical, and it is actually made up of separate vertical support structures that meet the requirements here, but it doesn't necessarily need that I connect them all together. As long as one meets the requirements, then I'm okay, and I can follow that application within the rule. All right? It goes on to say, it has an informational note that says, concrete installed with insulation or vapor barriers, film, or similar items separating the concrete from the earth is not considered to be in direct contact with the earth. So we kind of talked about that earlier. That informational note is awesome because it directly lets you know how you can actually take something that was be a concrete encased electrode, and depending on where you're at in the country, whether they require a vapor barrier or some kind of separation between the earth and the footing or foundation for whatever reason, then you remove the fact that you at that point don't have a concrete encased electrode. Okay? And if you don't have it, then it's not present. You see what I'm saying? So then you wouldn't need to tie to it. Okay, so that's the concepts that calls behind that, and that's what an informational note's just giving you clarity. Next, let's go on to A4, which is the ground ring. The ground ring, basically, it's just a bare copper conductor. I had people call me and say, well, can it be insulated? No, it needs to be a bare copper conductor. And it says a ground ring encircles. Okay, a ground ring encircling, not half mooning it. Not half mooning it. Encircling. A ground ring encircling the building or structure in direct contact with the earth consists of at least 20 feet, so it has to make up at least 20 feet. Could be more. If to encircle a building, you're probably going to get much more than 20 feet. But it has to, depending on the building size, it has to be at least 20 feet of bare copper conductor, not smaller than 2 AWG. Now, if the engineer requires it to be larger, that's an engineering rule. The NEC is a minimum standard, okay? And it can't be smaller than 2. Okay? Next is A5, dealing with rod and pipe electrodes. Now, this is ground rods, or it could be an actual pipe that's driven. Back in the old days, it used to be real common to drive pipes down into the ground. Okay? Now, let's look at it. Rod and pipe electrodes shall not be less than 8 foot in length. Okay? Could it be more? Obviously, yes. We've seen 10 foot. Okay? But it can't be less than 8 foot in length and shall consist of the following material. Okay? Caveat. If I install a 10-foot ground rod, 8 foot of it in contact with the earth, okay, would be okay. The point that's sticking up could be an impalement hazard, and that could be a problem. So always keep that in mind. But we're going to talk about not less than 8 feet, okay? And, of course, then we'll look at some of the rules for installation for all these as well. I didn't know I was going to go into that detail, but I guess I am, because I think I need to for clarity now. All right. So then you have under item A5, you have an A and a B. Let's read each one. Now, A says, grounding electrodes of pipe or conduit shall not be smaller than trade size 3/4. Okay, so that's your minimum. You have an exam question. If it's a pipe or conduit type grounding electrode, then 3/4. And it says, and where of steel, okay, so where this happens to be of steel type pipe or conduit, shall have an outer surface galvanized or otherwise metal coated for corrosion protection. Okay, rigid metal conduit does have an outer coating. IMC does have an outer coating, so you kind of get the point. All right. That by no means limits to those, but I'm saying those do have it. You do have EMT, which also I think you'd have a hard time driving that. But at the end of the day, we're looking for the outer galvanized or otherwise metal coating for corrosion protection applied. Now, B is for the rod type grounding electrodes. So it says, well, if I have a ground rod that is of stainless steel and copper or zinc coated steel, shall be at least 5/8 of an inch in diameter unless it is listed. Okay, so if I get one that's listed, it might be less than 5/8. Okay, but in reality, what we're dealing with here is a 5/8 inch one in diameter, and it shall be at least that, unless it is listed, and it might be a actual diameter might be less. Then there's a big argument in NEMA of the manufacturers. I think it's GR1 is the standard, or I think it's GR1, that they arguing over ground rods and what's 5/8 and whether the some that are listed are actually less diameter than 5/8, and why do we call those 5/8 if their diameter is actually less than a 5/8. If it's listed, in my opinion, if it's listed, then it can be used just like a 5/8. Okay, so anyway, some beg to differ. But anyway, so that's your minimum requirements for the ground rod. So if you go buy a ground rod, typically they're going to be a 5/8 inch ground rod. If you buy the copper or the stainless steel or the zinc coated steel, then that's what you're going to deal with. You can get some listed ones that would be less than 5/8, but look for that listing if you're going to do that. Okay. Other than that, stick with your 5/8. The next one is A6, and that is other listed electrodes. It says other listed grounding electrodes shall be permitted. Now, these are some of the ones that you can buy that are based on chemicals that you pour into them, and they leach out into the earth around it. And you have to keep those filled up from time to time, so there is maintenance involved with these. I am not familiar with the longevity of how often you have to fill these in or fill them up, or if there's a maintenance program on them. I don't know. You have to go to the manufacturer. But if it's a listed electrode and it has a listing for it, then it's going to be adequate and you could utilize it. I have not, in my career of 30 years, ever had the experience of dealing with it, but I understand that there's areas of the country where the resistance that's needed to get to the earth is hard to achieve, and some of these specialty listed products can allow it to be achieved. So they have these products available out there on the market. Most places I've ever been, I can achieve it. Oh, it's another thing to remind you. In all of the other ones that you have here that we've talked about, only the ground rods are the ones that, ground plates and things like that, have the application where you're dealing with the 25 ohms or less. Okay? That application is only applicable to rod pipes and plates. It's not to any of the other ones. Okay, and you find all that under 250.53A2, and there's an exception that talks about that 25 ohms or less. But it only talks about the rod, pipe, or plate. So really, even if I had a ground rod and I had two ground rods, and it doesn't matter whether, if I do two, I'm done. It could still be 250 ohms. It could be 300. It doesn't matter. That's only have to worry about the 25 ohms or less if I want to reduce down to one rod, pipe, or plate. But we don't really give any values of what that ohms value is needed. So I just wanted to kind of give you that 25 ohms or less only appears with the issue of the supplemental electrode requirement under a rod, pipe, or plate under 250.53A2. You don't see that 25 ohms anywhere with any of the other types of electrodes. Okay? All right, so now let's go on to A7. Now, A7 is the plate electrode. So we get the parameters for what qualifies for a plate. It says each plate electrode, and it literally as it sounds, it's a plate, okay? And that's it. It can be, we'll read it here. I'll read it for you in a second so you understand what we're dealing with the plate. It says each plate electrode shall expose not less than 2 foot, so it's 2 foot square of surface to exterior soil. Okay, so it's a fairly good sized plate. Electrodes of bare or electrically conductive coated iron or steel plates shall be at least 1/4 inch in thickness. Okay, so I could have copper plates, all right, but if I'm going to use a coated iron or steel plate, then it has to have at least a thickness of 1/4 inch. But even the bare ones are going to be at least 1/4 inch. And I have seen these, obviously I see them at a copper, but it doesn't give you any additional detail other than that. It just says, well, electrodes of bare or electrically conductive coated iron or steel plates shall be at least 1/4 inch thickness. Solid, uncoated electrodes of non-ferrous metals, okay, shall be at least 0.06 inches in thickness, which the non-ferrous is what we're getting into when we're getting into all those non-ferrous type of products. So that's what we just talked about. And so that's kind of where the copper kicks in. You see what I'm saying? So in that scenario, that's where you're getting that copper component kick into the requirement, because copper is non-ferrous. Incidentally, aluminum and aluminum alloys are also non-ferrous. But for our case, the copper versus what is ferrous, and that's things that have iron in it. Okay. All right. Let's see here. So let's get back to the code. All right. So if if it is iron, or if it's steel plates, then it's at least 1/4 inch thick. If it's a non-ferrous metal like copper, then it'll only be 0.06 inches in thickness. Again, when you buy that electrode, it's going to be, usually they'll be listed and you buy them that way. And they'll have the ability, and usually your exothermic weld to them, things like that. Okay, so that's a plate electrode, and we'll look at the installation requirements for that and all that as well. But let's finish this up. So A8, it says other local metal underground system or structures. Again, you only can go into 8 if A1 through A7 is not present. So then you got A4 through A8 that can be an option. And this one allows for other local meaning in the area of that construction for that project, maybe for that building. It might be a metal underground system or a structure such as a piping system, underground tank, or underground metal well casing that is not bonded to the metal water pipe. So it's not bonded to the metal water pipe. It's just an underground metal well casing that is there. Okay, it's not connected over to the water pipe application. Right, so that would be the allowance there. Because, of course, we can't use the water pipe to supplement a water pipe. So, anyway, got the language. So, at the end of the day, you have all these options here to be able to utilize. Okay? And so, that's the different electrodes we're dealing with. So, then let's kind of get into the installation requirements for each one of these a little bit. So, that gets us into 250.53. I said we wouldn't go there, but we're going to. Let's talk about rod, pipe, and plate electrodes. They have to be installed in accordance with 250.53 A1 through A3. A1 tells me, okay, rod, pipe, plate, that if practicable, I love that term, if practicable. I don't know that we have a definition for if practicable. It means that if you can do it, if you can get to it, it's practical to do it. If it creates some condition where it makes it not practical to do it, then it's not practicable. Then you wouldn't have to do it. But in most cases, let me say this. If I can drive a ground rod or put a plate in or a rod in, and I get it to that point, then it is entirely practicable to get it to that below that moisture level. Do people do it all the time? Absolutely not. They don't. So it might not be practical for some application. But let me read it here, and I'll kind of give you some scenarios where this might be the case. All right, so it says, rod, pipe, or plate electrode shall be embedded below the permanent moisture level. Rod, pipe, or plate electrode shall be free from non-conductive coatings such as paint or enamels. Okay, makes perfect sense. You don't want to put any of that on there that can impede the intimacy between the soil that it's being driven in and the conductive medium. Okay, we get it. Item number 2, it says, supplemental electrode required. So if I have a rod, pipe, or plate, it shall be supplemented by any additional electrode of the type specified in 250.52 A1 through A8. Okay? So in our case, other ones might be present, and so by connecting them together, we would be supplementing. But for most part, when people drive rods, it's because something else is not there. Okay, A1, A2, A3 is not present. They want to go the cheapest route. They just go to ground rods, and they drive ground rods, and that's perfectly fine. But you could supplement it by A1 through A8. And, of course, most people at that point will do what? They will go on and supplement the ground rod, because there's a whole reason they did the ground rod. They'll supplement it with another ground rod. Okay, A5 option. And it's perfectly acceptable to do. It says that the supplemental electrode shall be permitted to be bonded to one of the following. Okay, so I have the one, and the supplemental, I'm allowed to bond it from one rod to the other. Now, this is where people really get their minds blown here. So traditionally, we go from one rod and we loop over to another, or we stop at one rod and we put a bonding jumper over to the other rod, and they think that's the only way to do it, but it's not. So we're talking about the supplement electrode. It shall be permitted, not required, because I could just connect it to the rod, but I'm permitted to do it to any of these other applications or other points. Number 1 is rod, pipe, or plate electrode. 2, I could take it, that supplemental rod, pipe, or plate, and connect it to the grounding electrode conductor, okay, directly. Or I could take it over to the grounded service entrance conductor. That's the grounded conductor within the service equipment. Okay, that's where your grounding electrode conductor is originating anyway. So that allows me to take 2 separate, grounding electrode conductors, if you will, up to that point. The next one is a non-flexible grounded service raceway. So that would be our IMC, RMC, that whatever's got the service conductors coming in, most notably probably to your meter, then I could go or to the panel from the meter. Then I can go over there. If it's non-flexible, I can make the connection there. I don't know why you'd want to do that, but you could do that for the supplemental. And then the last one is any grounded service enclosure. So if it is a service enclosure, it is actually grounded, it's got its main bonding jumper installed, it's all connected, then I can take it over to any grounded service enclosure. Again, service enclosures, not remote distribution enclosures, service enclosures. Okay, so that's pretty neat. I can do the supplemental. So most people simply think you got to go from rod to rod, and that's what people mainly do, but there is other options here that many people kind of gloss over. Now, that's the supplemental requirement. Now, the exception says, well, look, if that single rod, pipe, or plate, and you test it, and its resistance to earth is 25 ohms or less, then that supplemental electrode is not shall not be required. That's a permissive statement. Shall not be required. 90.5. Can you do it? Absolutely. Do most people have the ability or have the equipment to test to get 25 ohms or less? And no, you can't do that with a simple ohm meter. People think it's got to be a ground earth resistance ohm meter or a meter that does that specific test or whatnot. Then easiest thing to do is drive another ground rod, put a bonding jumper between it, and move on. Another thing people seem to have a misconception is when the code says that your grounding electrical conductor is to be run to the grounding electrode unbroken, and you have some allowances for exothermic weld or whatnot, irreversible crypt. Reality is, if it's unbroken to the electrode, that first ground rod was the electrode. The additional ground rod is the supplemental, okay, or the supplement. Tying them together creates the grounding electrode system. However, that's a bonding conductor between one rod to the other rod, for example. And if that's the case, that if you're doing it from rod to rod, then in that case, then it doesn't have to be continuous through the first rod over to the second rod, okay? But if I'm going to do an individual one all the way back to the source or back to one of these other options, then those could be construed definitely as additional grounding electrode conductors. And you just have to follow the rules to determine whether or not it's a bonding jumper or it's actual a grounding electrode conductor to another electrode. All right, but anyway, following it all down here is important to follow all the nuances of how you do this installation. Most people will go, again, from rod to rod, and that's perfectly fine, or a pipe to pipe, or plate to plate, or whatever you would do. But you do need to understand you do have other options here, okay? And you want to understand how to size them, where the only caveat to that rule is that you're still going to size them the same way you would do the grounding electrode conductor to that specific electrode anyway. So if it was ground rod, it doesn't have to be larger than a 6 in accordance with 250.66a. It doesn't have to be larger. So if I'm connecting to another ground rod, then that jumper wouldn't have to be larger than a 6. So if I was taking it back to the grounding electrode conductor, then again, since it's a ground rod, then it wouldn't have to be larger than a 6. Okay, so that's kind of how you follow the concepts again. Very much dependent on sizing based on 250.66 based on the electrode itself. Okay? All right. Next one we'll look at is when you're dealing with that supplemental electrode that we're installing. If it is where you're going to deal with multiple rods, pipe, or plate electrodes, then they are to be installed to meet the minimum requirements of this section, but they shall not be less than 6 feet apart. Okay, so you do have an informational note that says, you know what, paralleling efficiency of rods is increased by spacing them twice the length of the longest rod. Again, probably comes from IEEE, but that's just an informational note. It's not required. So if you had an 8-foot ground rod for whatever reason, say a 10-foot ground rod for whatever reason, then they don't have to be 10 feet apart. If you had an 8-foot ground rod, which is your required minimum length, then no, they don't have to be 8 feet apart. Is it okay to be? Yes. Is it encouraged? Yeah. The efficiency of the rods increase due to its sphere of influence or cone of influence and how they overlap, and IEEE did something on that. But the reality is, per the code, they just can't be less than 6 feet apart. And, most inspectors will measure that. All right? Electrode spacing. So we read that, supplemental, 6 feet apart. Then it says, electrode spacing. Let's read it, as this is important. It says, where more than one electrode of the type specified in 250.52A5 or A7. And remember, A7 is the plate, A5 is the rod or pipe, okay, are used. Each electrode of one grounding system, including that used for strike termination devices, okay, that's the lightning aspect of it, shall not be less than 6 feet apart from any other electrode of another grounding system. So you definitely need to make sure that if you have a plate, a pipe, or a rod, that if you have other grounding electrode systems, even the strike terminals from the lightning aspect, or even their ground rod for their systems, that the rods itself have to be at least 6 feet apart. Okay, at least 6 feet. They can't be less than that. They have to be. Now, could they be more? Certainly. But they have to be at least 6 feet apart. Now, it says, we have two or more grounding electrodes that are bonded together. They are to be considered a single grounding electrode system. Okay? So the two rods, when they get bonded together, are part of your grounding electrode system. They work as one. Okay? Now, that's a system. But there's still one electrode that you're supplementing with another electrode. Okay? But just kind of, when you tie everything together, then it all works as one system. And that's what we're trying to do. We're trying to tie them all together as one. All right? Now, bonding jumpers. Kind of alluded to it when you're tying like rod to rod or whatnot together. Bonding jumpers. It says, bonding jumpers used to connect grounding electrodes together to form the grounding electrode system shall be installed in accordance with 250.64A, B, and E. Shall be sized in accordance with 250.66. And of course, because it says that, it doesn't say in accordance with table 250.66. So that's how we were able to say that if we have two ground rods, we can use 250.66A, which required it not to have to be larger than a 6 copper or 4 aluminum. Of course, you got to remember about terminating aluminum within 18 inches of the earth. That's not permitted. You're going to see in the 2020 code, you're going to be allowed to do that if it's done in a specific type of fitting. If they're going to be available on the market, then it might be less than 18 inches, but not under the 17 code. Okay, so as long as you meet all these requirements, then that bonding jumper doesn't have to be larger for any reason. So if it's ground rods, it's 6 gauge. From ground rod to ground rod, that's a bonding jumper. Doesn't have to be larger than what would be required to run to the grounding electroconductor. Also, just remember, another thing to remember is if I'm going from one grounding electroconductor to a ground rod, and I plan on jumping from that ground rod over to, let's say, a concrete encased electrode, and I want to kind of loop these, you can't do that. In other words, there used to be a term called the sole connection, and that's been removed from the NEC for clarity. And there's an extensive definition or explanation now when it comes to this connection scheme. Basically, remember this. I can't start with a smaller conductor and then go up in size to a different electrode that would require a bigger conductor. I can always go down. In other words, if I could go from the service panel to the water pipe ground, and that was, let's say, just for argument's sake, that happened to be a 2/0. I'm just using a number. And then I go from there to ground rods as that supplemental, because that is the electrode, and we were allowed to do that, if you remember earlier, and I talked about what you could take that supplemental to. I'm taking it to the grounding electrode. So if I do that, then that used to be considered, since it doesn't go anywhere beyond that ground rod, that is the sole connection to that ground rod. But everybody got confused on that. If that was the case, then I could go 2/0 to the water pipe, and then from the water pipe I could go with a 6 gauge to the ground rod, and then that was it. But I can't do it the other way. I can't go with the 6 to the ground rod and then jump up to a 2 and go to the water pipe ground. So you can always go larger and go smaller. You just can't go smaller and go larger. Just remember that when we do this daisy chaining. If you want to daisy chain electrodes, and you can do it, just remember that scheme. You can always start larger and go smaller. Keeping in mind that if you're going from one size to another size and then back up to another electrode that might require a larger size, like an in-ground steel, then you're going to have to size it based on whatever the end one would be, okay? Because you can't go back down and then try to go back up, Okay, so just think about that when you're designing your system. Okay. All right, and then of course D deals with for everybody to know where we're at. We're in 250.53. D was the metal underground water pipe, and it says, look, if used as a grounding electrode, metal underground water pipe shall meet the requirements of 250.53A1 and D2. We're assuming already at this point, if you're considering the use of a metal ground underwater pipe, that it met all of the requirements in 250.52A1, 10 foot in contact with the earth, any joint jumpers are installed, whatever you're doing, we'll assume at that point you've done it. Then you got to meet these caveats. And it says 250.53D1 and, it's not an or, and, so you have to meet both of these requirements. And it says, what does 1 say? It says the continuity. It says continuity of the grounding path or the bonding connection to interior piping shall not rely on water meters or filter devices or similar equipment. That's the whole concept of you having to put those jumpers in there that we talked about. You have to maintain that integrity. And we kind of talked about that when we looked at the requirements of 250.52A1, and we kind of got that flavor of what we were going to have to do. Then we got the requirements for the bonding jumpers and all the aspects of that in 250.53C. We didn't really look at 64A, B, and E, but that's not important at this point. We know we have to have those jumpers. So in this case, water pipes. So the integrity has to be maintained. We got that. Then it goes on and say, well, you know what? You're going to supplement it. And we kind of already went over that. I'm going to supplement that water pipe with an additional electrode of the type that's in 250.52A2 through A8. And you saw all the options that we had. Okay? It also reminds, I get a lot of people ask this question as well. They go, well, let's see, if I have the water pipe and I supplement with a ground rod, well, since it's a supplemental, I only need to install the one ground rod because it's supplemental. And I remind them to read the whole rule here. It says I could choose the supplemental can be of the type A2 through A8. It says if the supplemental electrode is of the rod, pipe, or plate type, it says it shall comply with 250.53A, right? And in 250.53A talks about the compliance has to meet all requirements of 250.53A1 through A3. So yes, you would have to supplement the ground rod or install two. Because if you lost the water pipe ground, the whole concept is you still have a compliant electrode system. And so you don't circumvent. I hear that all the time. If you go to water pipe ground, if I supplement it, I only have to install one. That is not true. It also goes on to remind you that supplemental electrode can be bonded to one of the following. To the grounding electrode conductor, to the grounded service entrance conductor, to the non-flexible grounded service raceway, any grounded service enclosure, okay, and it says as provided in 250.32B, okay. So I do have these options. Now, did you remember something that I said earlier? And I did this because I want you, hopefully, that you are scratching your head. And you say, well, why am I scratching my head? Because when it comes to the ground rods, it gave an application that says that I could connect it to a rod pipe ground. There's other aspects that I could connect it to. But here, when it said, well, wait a minute, if I'm going to supplement the water pipe, can I go from the water pipe to the actual electrode, the ground rods? And I don't know whether you caught it or not, but the answer is absolutely not. So remember I was giving you that example of daisy chaining, where I said you go to the water pipe and then from the water pipe you go to the ground rods? You can't do that in this application. Because what if you lose some portion of that water pipe ground? Then you've lost the connection to the system. So I did that on a purpose because I want you to think. That wasn't listed in the options that I gave you. So in this case, I'm supplementing a water pipe ground. It says the supplemental electrode shall be bonded to one of the following. And there's 5 options here. Grounding electrode conductor, to the grounded service entrance conductor, back in the service equipment, non-flexible grounded service raceway, any grounded service enclosure, and it says as provided by 250.32b. Now, it has an exception here. The exception says, you know what? The supplemental electrode shall be permitted to be bonded to the interior metal water piping at any convenient point as specified in 250.68c1, the exception. Okay, the exception. What does that mean? Well, that's an exception it talks about for an industrial, commercial, and institutional building or structure. If they have conditions of maintenance supervision that ensures only qualified persons service the installation, then the interior metal water piping portion located more than 5 feet from the point of entrance to the building shall be permitted as a bonding conductor to interconnect electrodes that are part of the grounding electrode system. So that's under that allowance for you to be able to utilize the water piping as an exception to the rule. Okay? But nowhere else in here would allow you to make that actual connection. Okay? And you're going to see something else. We'll talk about something a little more here in a minute when I start getting into the nuances for that. Most notably, I guess that we'll talk about the portion that enters 5 foot inside of the building for let's say even a residential application. But I don't want to dig too deep on that. We want to talk the basics, so we'll keep on from there, and then we'll kind of go back and work our way around to that. Okay? All right, so let's see. Well, you know what? Let's go on and cover it because I don't want anybody to get confused. So while you can't go from the water pipe over to, like, say, the ground rod because of the locations, and you saw the exception, when we are connecting all of the grounding electrode connections together and where we can go from, there is an allowance for us in 250.68C, and that says grounding electrode conductor connections. It says grounding electrode conductors and bonding jumpers shall be permitted to be connected at the following locations and used to extend the connection to the electrodes. Now, the very first one says interior metal water piping that is electrically continuous with a metal underground water pipe electrode and is located not more than 5 feet from the point of entrance to the building shall be permitted to extend the connection to the electrodes. Okay, so there's kind of a connection point, kind of a hub that you can connect from right there. Okay, it says the interior metal water piping located more than 5 feet from the point of entrance to the building is not to be considered a conductor. So we looked at that exception, and it talked about for industrial, commercial, institutional buildings, that is where it's visible, it's under maintenance supervision, then there is an allowance there to connect it at other locations on that interior water piping system. But under normal rules, you can only do it within the 5 foot point of entry. Now, why do we do that? Well, that's because typically that portion is not going to be replaced. If you have a water pipe ground, again, we don't see many today, but if you did, and it gets replaced, typically they're not going to replace the portion that comes into the building. And if they do, somebody's going to be aware of that, and they're going to make changes to the system. So that 5 foot that comes in, that is metal, if it is metal, at that point is where we would be able to use that as kind of a bridge point. Of course, you have all those other locations you can take it back to, the grounded conductor, service enclosure, and whatnot, non-flexible service raceway. You have all those other options, but you just need to know that it is acceptable to make that connection at the 5 foot point or less of where a water pipe comes in, a water pipe ground comes into the building, and you could do it there. All right, so that is an option. I just wanted to show you how you got there, okay, and that's how you would get there when you read it. Okay, the exception is specific, saying, look, that supplemental electrode can be bonded to the interior water pipe at a convenient point under 250.68C1 exception, and that's the points of more than 5 feet. That would be very much limited to a specific type of installation, commercial, industrial, institutional building or structure. Then you have that, and it's under maintenance and all this, and you can actually see the actual metal piping system. Maybe it's going down through a common chase or something like that. Then it would be acceptable to use the water pipe, interior water pipe, as that bridge, if you will. Okay? Otherwise, that's what you're getting. Now, the supplemental can be run to any of these applications here, but typically you are running it back to the grounding electrode conductor because you can use that under 250.68. You saw that first 5 feet can be used as a grounding electrode conductor. Okay, and of course we talked about that earlier, where the structural steel could also be used as a grounding electrode conductor if you meet all the caveats 250.68. Okay, so that's how you get there in order to take it to that 5 feet. But no, can you make the connection to the 10 foot that's out in the earth? Absolutely not. But if I even made it to the 5 foot point, okay, and I'm just going to a ground rod, then that is theoretically what we used to call sole connection, and it doesn't have to be larger than a 6 in that application. That portion is not the 5 feet inside. That portion is not the electrode. Okay, that's a permitted connection point that's considered a grounding electrode conductor at that point for that aspect of that installation. Okay, and that's what you'll see under 250.68, is because the whole title of that section is, and I'll read it for you. It actually says, let me get where it is. It says grounding electrode conductor, and that's what it says. And it says and bonding jumper connections to grounding electrodes, and that's what you're doing. Okay, so don't get overly confused there. All right, so getting back to that, so that's our water pipe ground, and then of course we get into E, which is supplemental electrode bonding connection size. All right, so it says where the supplemental electrode is a rod, pipe, or plate electrode. Here's what we were talking about earlier. It says that portion of the bonding jumper that is the sole connection to the supplemental grounding electrode shall not be required to be larger than 6 copper or 4 aluminum. Okay, so we still have some remnants there of the term sole connection right there. But again, I think you understand that sole connection is from one rod to another, one pipe to another, that type of thing. Okay. Ground rings. That's F. Ground rings. It says the ground ring shall be installed not less than 30 inches below the surface of the earth. Does appear on code exams from time to time. Ground ring depth. They'll try to put, the typical, they'll put, 36 inches, 26 inches, all of that. Just remember 30 inches below the surface of the earth. Okay? And that's another thing. 30 inches below the surface of the earth. Okay? Not the surface of the finished material. 30 inches below the surface of the earth. Okay? Now, G talks about those ground rods and pipe electrodes. We're not talking plate here. We're talking rods and pipes. It says the electrode shall be installed such that at least 8 foot in length is in contact with the soil. So I need at least 8 foot. If I drive it and only have 6 foot, I got a problem. So it says it shall be driven, not dug a hole in next to your foundation and just sit it in there and you're going to cover it when you backfill it. That's not going to work. It's got to be driven. It's the whole concept of it being driven down in the earth. Okay, so you have to do that first. So it shall be driven. That's a mandatory rule. And not less than 8 foot, except that where rock is encountered, or rock bottom is encountered, the electrode shall be driven at an oblique angle not to exceed 45 degrees from the vertical. Okay, or where rock bottom is encountered at the angle of up to 45 degrees. In other words, you can't do that either. So really, they want you to drive it, okay, straight down or at a 45. If you still can't, then the electrode shall be permitted to be buried in a trench that is at least 30 inches deep. The upper end of the electrode shall be flush with so no, that's just allowing you to lay it in the trench. Got that right? Now, it also goes on to say, look, the upper end of the electrode shall be flush with or below ground level unless the above ground end and the grounding electrode conductor attachment are protected against physical damage as specified in 250.10. So this is an example where I have maybe a 10-foot ground rod, and I drive it, and I got my 8 foot in contact, and I got a portion that's above the ground. And I'm above it. I have to protect it from physical damage, something banging into it, something cutting it loose. I still have to have 8 foot in contact with the earth. Okay? So here it's saying, look, maybe you use a ground rod that's longer than 8 foot. That's fine. It's at least 8 foot. So if it's longer, then at that point, I have to be able to make that connection. If it's above ground, okay, where I'm making all these terminations or attachments, then I got to protect that termination. I don't know how many times I've gone to job sites and I've seen the actual acorn clamp or whatever just broken or spinning or not. It's not there. Okay. Remembering again, we're not trying to clear overcurrent devices. We're not trying to do anything with that except for lightning transient, surges, stabilization, all that good stuff. Just remember, we're not trying to clear overcurrent devices. Yet that doesn't negate the fact that it needs to be a good, solid connection. Okay. Using a listed fitting for that. And most notably, the listed fitting if it's designed for a rod or for pipe. Some of the clamps you can get will do rods and pipe, depending on how you turn over the end. There are some clamps that are rod specific. You can only use them for ground rods, okay, like an acorn clamp. And obviously, you want to get those that are rated for direct to burial as well. Next is the plate electrode. That's H. So we're dealing in 250.53H. So what are the nuances to a plate? Well, the plate electrode, we know it's got to be 2 foot square. We also know that it's got to be, if it's iron or steel, some kind of electrically conductive coating, then it has to be 1/4 inch thick. If it's copper, it's 0.06 inches thick. Can it be thicker? Certainly, if you want it to be. Copper's not cheap, so whatever. It says the plate electrode shall be installed not less than 30 inches below the surface of the earth. Again, below the surface of the earth. Then it gets into 250.54. It's just I'll just touch on this one. This is called auxiliary grounding electrodes. What does auxiliary mean? It's not required. It's not a supplemental. It used to be called supplementary. There's certain pieces of equipment for static discharge that will ask you to install an auxiliary. A lot of times at the pole lights that we see at parking lots, you'll see ground rods driven. You don't have to have two, only one, unless they ask for two, because that's not a supplementary or that's not an electrode. That is an auxiliary grounding electrode. Remember the difference. It says one or more grounding electrodes shall be permitted to be connected to the equipment grounding conductors, okay, specified in 250.118, and shall not be required to comply with the electrode bonding requirements of 250.50 or 250.53C. Okay, and in 250.53C was the bonding together of other electrodes and things like that. It's not required to do all that. Or the resistance requirements in 250.53A2 are not required. In other words, you don't have to worry about the 25 ohms or less. It's not playing a role. It's auxiliary. It's extra. Do what you will. In fact, it doesn't even say what size conductor you have to run to it. Okay? So you do whatever size that you want to. It's auxiliary. Okay? Usually the manufacturers will give you the parameters necessary to whatever to run, okay, for that piece of equipment that it's being installed next to. So just be careful that you don't accidentally tie that with the system and then you create differences of potential, okay? It's an auxiliary. It's designed for a specific intent, okay? Okay. It says... let me read all of it here, just so we get it all. It says, exception, but the earth shall not be used as an effective ground fault current path as specified in 250.4A5 and 250.4B4. Okay? So, again, you don't have to meet the resistance requirements in 250.53A2 exception, but remember that the earth is not to be used as an effective ground fault current path. It's just another reminder that it states that in 250.4A5 and 250.4B4, and I don't think you do that. Most of the time what happens here is that it's a machine that creates static. It's like a conveyor system or some kind of static buildup, and they need to have an effective discharge, and they might mandate in their equipment, they might want something that says install an auxiliary grounding electrode. Okay? And then you would install it. One example might be if I have a generator and the generator is not a separately derived system. And if it's not a separately derived system, then it's just another piece of equipment. And if that's the case, I don't want to drive ground rods at it. You don't drive a grounding electrode system to it. But the manufacturers might want an auxiliary grounding electrode based on their application, and that would simply connect to the frame, but it most certainly is not going to connect over to the grounded neutral conductor. Okay, so that could be an auxiliary grounding electrode that the manufacturer wants you to install. Another example might be in a conveyance system. I used to, back in Virginia, there's a place that used to produce spices and everything in Richmond. And I think it was Sauer's building, the Sauer. And you had a lot of equipment that could create discharge, and a lot of times specifications might require ground rods driven at certain types of conveyor equipment. But it's for static discharge. It was done by the manufacturer of that equipment. It wasn't to be construed as a grounding electrode system for the building. It wasn't a supplemental electrode for the building. It was auxiliary, which used to be called supplementary. It was additional for that specific piece of equipment, and that's how you treat it, okay? All right, well, you know what? That is absolutely all we're going to discuss in this episode. I don't want it to be longer. It's an hour and 30 minutes on that. That's kind of giving you the overview of electrodes. We could go in more detail. I probably left out one or two things involved, and I'm sure some critic out there will say. But of course, the ones that say that usually don't have a video or a podcast of their own to reference, because everybody likes to be a critic these days. Nobody wants to produce. They always want to comment on stuff. So hopefully this helped you. If you have any questions and you would like them answered on these topics, remember, you can always email us at info at masterthenec.com or info at electricalcodeacademy.com, or you can even go to our websites and you have a contact button. Send us a question on the contact form. You can type in whatever you want. If you don't want to send an email, that's perfectly fine. If you don't want, that type of thing. Of course, I got to know how to get back in touch with you. So at the end of the day, you got any questions, remember, you can always reach out to us. We're here to help. That's what our focus is. For any of you that actually make it to the end of our podcast, man, you're a trooper, because people tell me that they really have an attention span of about 5 minutes, and some of my podcasts or my videos can go on a long time. I'm sorry. It's just the best I can do. If you want to stop listening at some point, that's up to you. But I got to give you everything I can give you. So until next time, folks, stay safe and God bless.
Every day, the future's getting closer. Every day, the future's looking bright. Every day is another beginning.